वेलकम माय डियर स्टूडेंट। कैसे हो आप लोग? आई होप तुम लोग बहुत अच्छे से पढ़ाई कर रहे हो। तो मैं आज आप लोगों के लिए एक नया चैप्टर लाया हूँ थर्मोडायनामिक्स का, जो बहुत इम्पोर्टेंट चैप्टर है। वो है डिग्रीज ऑफ फ्रीडम। टुडे आई शैल गिव यू द डिटेल्स थ्योरी ऑफ डिग्रीज ऑफ फ्रीडम, इंक्लूडिंग some important relation and numericals, which will 100% help you in your future examination. You may already know about the degrees of freedom, but today we shall learn it in some easiest way. If you like my video, then subscribe my channel for new interesting video, and also comment that how my teaching was good or not satisfied you. So I will try my level best to increase to do it better. So let us start. Degrees of freedom. Degrees of freedom. Degrees of freedom is independent coordinates. Degree of freedom means independent coordinates or independent quantities, which by which we can describe a system fully, by which we can describe a system, a thermodynamic system. So if we write the definition of degrees of freedom, we can write it, that is the number of independent quantities, number of independent quantities required to describe the position and configuration of a system. Here system means thermodynamic systems. So the number of independent quantities required to describe the position and configuration. Configuration means the number of atom, arrangement of atom in space. So this is the basic definition of degrees of freedom. Now let us do it with some example. First we shall go with a single particle system, that is for monoatomic gas, single particle system. A particle have three type of kinetic energy. Number one is translational, number two is rotational, and number three is vibrational. These three types of kinetic energy is associated with every molecule. Now, if the single particle, for single particle, if the particle goes along a particular direction, that is say x axis, if a particle, suppose this is a particle or any man goes along x axis, then it's have only translation motion, no rotation or vibrational motion. So for one dimensional motion, it has required only one coordinate. For two dimensional motion, that is if it is along a straight line. For two-dimensional motions, it has two coordinate, that is for a plane x, y, y, z or zx plane. And for three-dimensional motion, that is in space, to express its position, we require three coordinates, that is in space. So, if we summarize it, that for a single particle in space, the number of coordinates required to express its position is 3. So, it has only translational kinetic energy. So, for a single particle, if we go with single particle system or monoatomic gas, so for monoatomic gas, mono means one, that is a gas molecule which constitute only one atom, that is the noble gas helium, argon, neon, etc. For monoatomic gas, the degrees of freedom is 3 because here the total energy is given by half m vx square, half m vy square and half m vz square, that is fully translational. No rotation, no vibration, only translational kinetic energy for monoatomic gas. So, it has only 3 coordinates, half m vx square, half m vy square, half m vz square. So, for monoatomic gas, the degrees of freedom is only 3. Now, for diatomic gas, example is O2. It has both translational and rotational kinetic energy at low temperature. Obviously at low temperature, because when the temperature is high, then vibrational kinetic energy is also included to it. So, for monoatomic gas, the degrees of freedom is 3. For diatomic gas, we have both translational and rotational kinetic energy. How many translational? 3. And how many rotational? 2. So, for diatomic molecule, here not single particle, for diatomic molecule, the degrees of freedom F equal to 3 plus 2 equal to 5. Here vibrational energy is not required because the temperature is low. But when temperature is high, then degrees of freedom will be 3 plus 2 plus 2 equal to 7 at high temperature. Because then 3 translational energy, kinetic energy, 2 rotational and 2 vibrational kinetic energy is added. But this is not observed with experimental fact. So, we can discuss it later. Now, the question is, what are the terms? What are the 3 rotational, 3 translational and 2 rotational energy? You understand the 3 translational energy is the velocity component along x, y and z axis, that is Vx, Vy and Vz. So, the corresponding term we have written that half m Vx square, half m Vy square and half m Vz square. Now, what about the rotational kinetic energy? Let us understand this picture. Suppose this is a diatomic molecule. This axis is taken as Z axis, this axis is taken as X axis, and the axis this is taken as Y axis. Now this molecule, diatomic molecule, are two molecules who are separate at a fixed distance. Their separation is fixed. In practical, we have say it dumbbell shape, or in physics it is also called rigid rotator. Now, how can it rotate? It can rotate along mutually perpendicular axis passing through its center of mass. Now, for two diatomic molecule, if this is hydrogen, then two diatomic molecule, the center of mass is along their center of their axis. Now, this can be rotated, if x axis along, this can be rotated along this direction. So, this can be rotated along in this way. It can be rotated along this rotation y axis. In how? If this is y axis, then it can be rotated along this. Along x axis, this is rotated along this position. Along y axis, this is rotated along this position. So here we can get the kinetic energy, that is rotational kinetic energy. If we say it ER, rotational kinetic energy is, we know that the formula of rotational kinetic energy is half Ix omega x square, where I is moment of inertia, plus along y axis half Iy my square. But what about z axis? Sorry, what about z axis? It does not rotate about z axis. It can only rotate along this position on z axis. Now, according to kinetic gas theory, the molecule has point mass. So, their size is very small compared to the volume of the gas. So, if we say that the moment of inertia Iz equal to what is m into r square. Now, what is this r? R is this distance. This small distance is r. Now, if we rotate along z axis and it also lies along z axis, so this distance is very small compared to the negligible. So, we cannot write the term Iz square. So, for rotational kinetic energy, it has only two terms, half Ix omega square, half Im Iy omega square. So, now this 5 terms comes from, as the total energy is E translational plus E rotational. Translational is 3 half m Vx square plus half m Vy square plus half m Vz square and half Ix omega x square plus half Iy omega y square. So, we can take that 1, 2, 3, 4, 5, the 5 terms we get. So, for diatomic molecule at low temperature, we can get only 5 degrees of freedom. If the temperature is high, then we can also get vibrational kinetic energy, which is the sum of kinetic energy plus potential energy. The formula of kinetic energy is half mu v square plus potential energy is half of k r square, where mu is reduced mass of the system and k is the force constant. So, for high temperature, the degrees of freedom will be 3 plus 2 vibrational, that is 7. But this theory is not goes with experimental fact. So, we cannot discuss with it. We can discuss another molecule, that is polyatomic or triatomic molecule. I hope you will find interesting it. Don't skip my video, please see it till the end. If you 100% you will be helpful and utilize it in your future exam. Triatomic molecule have two different configuration. One is linear and other is along triangular. Now linear is like carbon dioxide, triangular is like H2O. This is the shape of carbon dioxide molecule. So here if we take that the three molecule are bounded by two force of constant. Here the fixed separation is called force of constraint. Constraint means hinder or badha. So for one molecule the degrees of freedom is 3. So for 3 molecule the degrees of freedom will be 3 into 3, that is 9. But they are separated by two force of constant. So this is subtract from this. So for linear triatomic molecule the degrees of freedom is 7. And for triangular molecule, for each molecule degrees of freedom is 3 into 3, but the here force of constant is 1, 2, 3 minus 3, that is 6. So this can be written in general form that the degrees of freedom F equal to 3 into 3n minus k, where n is the number of particle, k is the force of constant. Sorry. So here if we put 3 here and k is equal to, we can get 7 for linear, and for triangular we can get the value of F is 6. This 7, why this is 7 and this is 6? Because at low temperature carbon dioxide, carbon monoxide has vibration at room temperature. So the two vibrational terms can be added with degrees of freedom. So the degrees of freedom is 5 plus 2, 7. But here no vibration occur. So the term is 6. So if we summarize it, we can get that monoatomic degrees of freedom DOF, that is for monoatomic degrees of freedom is 3, for diatomic degrees of freedom is 5, and for triatomic or polyatomic degrees of freedom is either 7 or 6. I hope you understand this theory. Now we can find out the ratio of Cp and Cv, and what is the relation between degrees of freedom and Cp is Cp. To understand this, we can go with a basic law, equipartition of energy. Equipartition of energy says that for a molecule, average energy associated with each degrees of freedom is half kT, where k is the Boltzmann constant. For a molecule, average energy associated with each degrees of freedom is half of kT. So this is the basic equipartition of energy. So if we take monoatomic gas, then the average energy per molecule equal to, now what, half kT into number of degrees of freedom is 3. Each degrees of freedom is half of kT. For we can learn that the monoatomic molecule, the degrees of freedom is 3. So the average energy per molecule is 3/2 kT. Therefore average energy per mole means Avogadro number, that is 32 kT into multiplied by Avogadro number. Now this K into Avogadro number is equal to R. So 32 RT. R is molar gas constant, you know. K into Na equal to R. So average energy per molecule, if we say it U, internal energy, that is 32 RT. Now what is the value of Cv? Because gamma is the ratio of Cp and Cv, we know. Then therefore the value of Cv, that is molar specific heat at constant volume, equal to du dt, that is 3/2 R, and Cp equal to Cv plus R, that is 3/2 R plus R, that is 5/2 R. So what is the value of gamma? Cp by Cv, that is 5/2 R by 3/2 R, that is 5/3, 1.67. So for monoatomic gas, the value of gamma is 1.67, which is very strongly agrees with the observed experimental fact. The basic relation for diatomic molecule and for triatomic molecule. For diatomic molecule, U equal to 5/2 kT into Na, that is 5/2 RT. Therefore Cv equal to du dt, that is 5/2 R. Cp equal to Cv plus R, that is 5/2 plus R, that is 7/2 R. Therefore gamma equal to Cp upon Cv, that is 5/2 R by 7/2 R, 5/7, that is we can know write it 1.4. We know the value of gamma equal to 1.4. For triatomic molecule, U equal to 7/2 RT, right? Sorry, 7/2 RT. Therefore Cv equal to, here 7 is the degrees of freedom for which molecules? Linear molecule. Therefore Cv equal to 7/2 R and Cp equal to 7/2 R plus R, that is 9/2 R. Therefore gamma equal to Cp by Cv, that is 9/2 R by 7/2 R, that is 9/7 equal to 1.28. So we can take the value of gamma, gamma mono, gamma di and gamma tri or polyatomic molecule. This will go strongly with the experimental fact. Now what is the basic relation? If we prove the basic relation between a gamma and degrees of freedom, so let us prove this. This proofs will very much important in your coming exam. In general, that is, let us take 1 mole of ideal gas. Therefore, average energy per molecule equal to ideal, let us take 1 mole of ideal gas, 1 mole of monoatomic ideal gas, here monoatomic. So average energy per molecule is, we know, 32 kT into, oh sorry, 3 to, we cannot write it 3 equal, that is degrees of freedom into half of kT, because we cannot put it 3 by 2, because we can prove it in general. So average energy per mole is Na into F by 2 kT. Now Na and K means R, that is F by 2 RT. Therefore Cv equal to, if this is E or U, then Cv equal to du dt. Let us just take it U, du dt. So what we can get? F by 2 R. Therefore Cp equal to Cv plus R, that is F by 2 R plus R, that is, if we common R, then we can get F by 2 plus 1. Then gamma equal to Cp by Cv, that is R F by 2 plus 1 divided by, what is the value of Cv? F by 2 R. So R will be cancelled, so we can get F plus 2 by F, that is 1 plus 2 by F. So the basic relation is gamma equal to 1 plus 2 by F. From this we can easily find out any problem. If we can say that the gas is monoatomic, we can write F equal to 3. For diatomic, we can write F equal to 5, and for polyatomic, which is linear, F equal to 7, or if this is at the vertex of a triangle, or that is triangular, that is F equal to 6. In this way, we can find out the value of gamma, and by which we can, knowing gamma, we can find out the velocity of sound, that is gamma equal to root 3 p by rho, and many other problem. Next day I can go with only 3 problems, and these 3 problems are very important for your joint entrance or medical examination, or please watch these problems in the later videos. 100% it will help to understand this, and the problem I shall discuss in later is very much important. So if you like my channel, please subscribe and press the notification bell, and please comment that how you like it. Thank you.